The next major global price war is not going to be fought over crude oil or even silicon microchips. It is going to be fought over the cost of a single generated word.
Right, because at this exact moment, a severe pricing spread has emerged in the frontier artificial intelligence market.
Exactly. Let us look at the numbers. DeepSeek currently charges 28 cents for 1 million output tokens from its V4-Flash model. You compare that to OpenAI's cost-focused GPT 5.6 Luna, which charges $1.20.
And then you look at Anthropic's introductory Sonnet 5 rate, which sits at $10.
$10. Now, these models are engineered for different levels of capability, speed, and reliability. So this is absolutely not a clean apples-to-apples performance ranking.
No, is not. However, a spread that moved from 28 cents to $10 is simply too wide to dismiss as a temporary promotional footnote.
Advanced AI is becoming cheaper, and it is happening faster than nearly anyone in the enterprise software space modeled for. Today, we're analyzing a comprehensive stack of institutional research regarding frontier AI pricing.
And our objective here is to determine exactly how this shifts capital allocation, corporate strategy, and geopolitical leverage.
The immediate reaction across the market was that Chinese developers have effectively made intelligence free.
But, if you look closely at the balance sheet realities and the infrastructure costs, they have not made intelligence free. What they have done is made every premium significantly harder to defend.
For several years now, the fundamental commercial logic of frontier AI rested on physical scarcity. Building strong models required leading-edge chips, incredibly expensive data centers, specialized research teams, and massive access to power.
Right, and that scarcity supported premium API prices. In turn, those premium prices helped justify the unprecedented capital expenditure behind the global AI build-out.
DeepSeek is attacking that entire chain, but they are doing it from the efficiency side. They are offering long context windows, reasoning, tool use, and open model weights at a price point that forces enterprise buyers to ask a different question.
The central question is no longer which model scores highest on a public benchmark.
Exactly. It is which model delivers usable work at the lowest total cost.
And this is where the accounting gets critical. Total cost is not the token bill. The list price is just the starting point of the operational equation.
Because a cheap model might need more retries. It might require tighter supervision or a higher degree of human correction.
Precisely. A premium model might execute the task correctly on the very first attempt. You frequently encounter situations where the raw invoice heavily favors one model, while the actual corporate workflow heavily favors another.
I want to push back on that immediately. If you are running a technology budget right now and you see that DeepSeek is offering reasoning capabilities for literal pennies, why would you ever approve a $10 Anthropic charge?
Well, it comes down to risk management.
It feels like buying a $10,000 calculator. Is it just institutional inertia and brand loyalty?
No, it is the total operating cost. That includes the model price multiplied by the number of tokens, plus the retries, the tool calls, the system integration, the latency, and crucially, the cost of human review and errors.
Let us consider a high-stakes scenario to illustrate that.
Contrast a 28-cent token run that hallucinates a subtle bug into a global bank's payment routing code.
A bug that requires, say, $5,000 of senior software engineering time to identify and fix.
Right, versus a $10 token run that writes the code perfectly the first time. In that specific workflow, the $10 model is drastically cheaper.
Which gives enterprise buyers a much better, more rigorous procurement metric to track cost per accepted outcome.
That metric asks a highly specific question.
How much did your company actually spend to produce one single answer that successfully passed your internal quality, security, and compliance thresholds?
Precisely. You also have to examine the mechanics of how data is processed under the hood. Tokenizers, the systems that break text down into readable chunks for the AI, can count the exact same document differently.
One model might compress a legal contract into 10,000 tokens, while another might need 15,000 for the exact same text.
Furthermore, some systems utilize more hidden reasoning tokens to arrive at an output. A lower price per million tokens can quickly evaporate if the model takes a much longer, more convoluted path to completion.
Once buyers begin to measure this cost per accepted outcome rigorously, the premium models are not automatically threatened, but the burden of proof shifts.
Yes, because when the list price gap reaches multiples of cost, rather than just a few percentage points, the enterprise routing system becomes a very powerful financial control mechanism.
Routine data extraction can be routed to a low-cost model. Complex, multi-step reasoning can move to a premium system.
And highly sensitive proprietary work can stay entirely inside a local on-premise model.
Once customers have the infrastructure to switch models task by task, the frontier laboratories lose a significant degree of control over their gross margins.
That is the core procurement reality. But to understand how a 28-cent list price is even physically possible, we have to examine the engineering levers.
We need to look at the production efficiency of the architecture itself. DeepSeek utilizes what is called a mixture of experts, or MOE architecture.
Think of this mechanism like walking into a massive hospital.
If you walk into the emergency room with a broken arm, the hospital does not page every single oncologist, neurologist, and pediatrician on staff.
They route you directly to the triage nurse and the orthopedic specialist. DeepSeek does the exact same thing with computation,
It does not activate its entire neural network for every single token it processes. It routes each piece of work through a smaller group of highly specialized components.
which physically reduces the amount of electricity and compute required to generate a response. The financial effect of that architectural choice is entirely physical.
Inference, the act of the model generating an answer, consumes accelerator time, memory bandwidth, network capacity, electricity, and cooling.
So if the architecture requires less active computation per word, the cloud provider can serve a significantly higher volume of requests from the exact same hardware footprint.
They are also utilizing sparse attention methods designed specifically to reduce the cost of processing long documents.
And then there is the mechanism of caching. This is essentially computational memory.
It is like when I ask you the same logistical question 3 times in 1 week. By the third time, you do not even have to think about it. You just give me a pre-recorded sigh and the answer.
Well, AI providers are doing exactly that with corporate data. If an enterprise assistant repeatedly receives the exact same employee policy manual or the same software repository, the provider can reuse a massive portion of the earlier computation.
They do not have to process the input from zero every single time.
But to maintain analytical balance, we must note that Chinese developers did not invent every one of these commercial levers.
Right. Western cloud providers heavily utilize smaller specialized models, prompt caching, batch processing, and lower priority service tiers.
The broader structural shift here is that intelligence is no longer being sold as a single undifferentiated product. It is being broken apart and priced by capability, latency, timing, and service level guarantee.
Which brings us to a major macroeconomic debate, the rebound effect. There is a thesis that falling prices will destroy industry revenue.
But historically, making a useful input cheaper does not reduce society's demand for it.
It is like widening a major highway to reduce traffic congestion. What actually happens?
The driving experience becomes easier, so thousands of additional commuters decide to drive, and suddenly your new 10-lane highway is completely jammed again.
The Jevons paradox tells us that efficiency increases consumption. Supercomputing historically put software into more departments and more devices.
Artificial intelligence could easily follow that exact historical pattern. If the cost for task falls by 90%, but global usage rises 20-fold because suddenly every small business can afford it, total infrastructure spending still doubles.
Cloud providers sell more inference hours. Data centers process millions of additional requests. Unit prices decline, but the total addressable market expands massively.
This dynamic is the strongest defense of the ongoing infrastructure boom we are seeing in capital markets today.
That may be true for the infrastructure layer, but the application software layer faces a much more hostile equation.
Traditional software as a service, or SaaS, benefits from near-zero marginal reproduction costs. Once the code is written, selling one more subscription costs almost nothing.
AI is fundamentally different. It adds a variable physical compute expense every single time a customer asks for work.
And that variable expense is highly dangerous for fixed-price software. If a company charges $20 a month for a polished AI interface, they cannot allow users to run unlimited autonomous agents, web searches, and heavy research tasks on the most expensive underlying model.
Their gross margin would evaporate in days. They're forced to manage usage.
Exactly. DeepSeek's pricing accelerates the destruction of the software wrapper business model. A software company simply cannot defend a massive markup forever if their only value proposition is putting a nice user interface over intelligence that the customer could buy directly for pennies.
The defensible value for those application companies has to sit in what the base model does not inherently possess.
Proprietary internal data, deep workflow integration, regulatory approvals, and the willingness to take legal and professional responsibility for the final result.
Drafting a standard legal clause is becoming incredibly cheap. However, connecting that specific clause to a law firm's historical precedents, securing client permissions, routing it through the billing system, and attaching professional liability to it, that does not become cheap.
The intelligence itself is acting like a commodity input, but trusted, integrated execution remains highly scarce.
If we follow this trend from the software layer down to the physical data center, the dynamic gets even more complex. The surge in usage and efficiency alters how big tech justifies its massive capital expenditure.
Because every single digital request still lands on physical infrastructure.
Right. The data center experiences two conflicting forces simultaneously. On one hand, better architecture reduces the compute load per individual request.
On the other hand, complex agentic workflows drastically increase the total number of requests. The system has to plan, call a tool, check the result, realize it made a mistake, and try again.
This is exactly why DeepSeek's extreme efficiency does not automatically translate to a collapse in long-term chip demand.
The total hardware demand might not drop, but the mix of hardware inside the facility will likely shift.
Training frontier models still requires highly flexible, premium systems. Large-scale routine inference, however, can increasingly be shifted toward cheaper, highly specialized custom chips designed specifically for narrower workloads.
Hardware demand continues to grow, but pricing power begins to move from one category of semiconductor to another.
We are also seeing providers price this intelligence exactly like traditional cloud infrastructure.
Alibaba publishes distinct prices based on the model tier, the geographic region, the context length, and the service mode. Google supports batch processing and priority routing.
Anthropic and OpenAI charge different rates depending on data residency options and speed. The token price is becoming just one single line item on a much larger enterprise cloud bill.
That transition fundamentally alters how these companies recover their initial capital investments. A frontier laboratory spends billions before it earns a single dollar.
The training phase requires massive upfront capital. The serving capacity requires even more.
So if the price of an API call falls aggressively, that company has to compensate. They need lower serving costs, significantly higher utilization rates, massive volume, or they need to generate revenue somewhere else entirely.
This highlights a structural disadvantage for standalone AI laboratories. They rely entirely on direct subscriptions, APIs, and licensing.
But big tech, both in the West and China, has alternative revenue streams. They can use AI as a loss leader.
Alibaba can use its Quen models to attract broader, highly lucrative cloud infrastructure workloads.
And Baidu can distribute its ERNIE system across search products and enterprise services to drive engagement.
Exactly. The AI model itself can carry a razor-thin or even negative operating margin if it helps the parent company secure a massive enterprise contract.
Baidu recently stated that their ERNIE 5.1 model utilized only a fraction of the pre-training compute compared to models of a similar scale.
Whether that corporate claim is entirely accurate or not, it indicates where the commercial battlefield is shifting. It is not just about achieving cheaper inference, it is about achieving cheaper initial model development.
Which forces investors to answer a two-sided question regarding capital expenditure. Does algorithmic efficiency actually reduce the total hardware required for AI?
Or does it make AI so affordable that society consumes vastly more hardware overall?
The answer to that relies entirely on demand elasticity and geopolitical constraints.
Geopolitics is the invisible hand guiding this specific pricing structure.
United States export controls heavily restrict China's access to advanced computing chips, high-bandwidth memory, and semiconductor manufacturing equipment.
Those measures drastically raise the financial cost and physical difficulty of brute force scaling for Chinese developers.
But wait, does that not just choke them out? If they cannot acquire the hardware, how are they fundamentally keeping pace with Western labs?
Because the controls do not remove the economic incentive to compete. They simply increase the premium on software engineering that can extract maximum performance from constrained, older hardware.
So DeepSeek's highly sparse architecture and its aggressive focus on efficiency are direct adaptations to that constrained environment.
For Chinese developers, hardware scarcity has become a foundational design requirement, rather than just a supply chain inconvenience.
And this constraint is driving the release of open weights, which completely shifts the geography of global AI adoption.
If you are an enterprise in Southeast Asia, Latin America, Africa, or the Middle East, you can download a Chinese open weight model, adapt it to your specific regional needs, and run it on your own local infrastructure.
The original Chinese developer does not need to own the direct customer relationship for their model to become the regional standard.
This creates global influence through underlying technical standards rather than direct software subscriptions. Local developers build their internal tools, their fine-tuning methods, and their security protocols around that specific open model.
A temporary price advantage today can mature into a deeply entrenched, highly durable software ecosystem tomorrow.
For nations that are highly wary of total dependence on American technology platforms, these low-cost open models provide critical geopolitical bargaining power and sovereign control over where their domestic data is processed.
However, for heavily regulated Western enterprises, there is severe compliance pushback. Running open weights transfers the entire burden of responsibility to the user.
Open weights do not come with guaranteed secure deployment, they do not offer reliable security updates, and they certainly do not provide contractual legal support.
A European bank or an American defense contractor faces a radically different total cost calculation.
Right. Data residency laws, rigorous cybersecurity reviews, sanctions exposure, and strict procurement regulations heavily influence the enterprise decision.
A model that cannot pass a bank's internal control environment is not commercially cheap, regardless of what the token invoice says.
The United States still retains massive structural advantages that simple token pricing cannot erase: leading semiconductor design, massive integrated cloud platforms, and deep enterprise distribution networks.
So, combining the pricing pressure, the architectural shifts, and these geopolitical factors, what is the structural reality of the market over the next 2 years?
Based on the data, the outcome points toward a barbell market structure.
A barbell market means the extremes thrive while the middle gets crushed.
On one end of the barbell, commodity intelligence operates exactly like a public utility. It handles routine, low-risk extraction and basic drafting at rock-bottom prices.
On the other end, trusted premium execution survives and commands high margins because reliability fundamentally changes the economics of the task. Think cyber defense, complex financial compliance, or autonomous pharmaceutical research.
The middle segment of the market is the danger zone. Any model or software wrapper attempting to charge premium prices without offering a measurable advantage in performance, accuracy, or strict data control will face severe, potentially terminal compression.
This requires an entirely new scorecard for capital allocators. Moving forward, investors cannot simply track the price per million tokens. That is a vanity metric.
You need to measure the tokens required per completed task. You need to measure the first-pass acceptance rate.
You must track the gross margin after inference costs, the switching costs for the customer, and the total cost of human review.
And governments need a different scorecard altogether. They have to measure their dependence on foreign model weights, their sovereign control over cloud capacity, and their domestic engineering capability to adapt and secure these models locally.
Before we wrap up, there is one final strategic implication to consider. If artificial intelligence truly becomes as cheap and abundant as electricity, what happens to the human skills that historically commanded massive premiums?
If a machine can write syntactically perfect code for pennies, perhaps the most valuable skill of the next decade will not be writing code at all.
The premium will shift to the people who possess the domain expertise to know which complex problems are actually worth solving in the first place.
To summarize the data we have reviewed today, the AI race began strictly as a contest over who could build the most capable, intelligent model. China has forced a secondary contest onto the enterprise balance sheet.
The global contest is now about who can deliver sufficient intelligence at a total operating cost the customer is actually willing to accept.
The immediate financial winners are the enterprise buyers, the companies building intelligent model routers, and the highly efficient cloud platforms.
The losers are undifferentiated models burdened with massive development costs and thin software wrappers whose only product is marked up access to someone else's intelligence.
Ultimately, the winner in this market will not necessarily be the company selling the cheapest token. It will be the company that delivers the cheapest final result the customer trusts, utilizing proprietary data and measurable operating leverage. Subscribe to the Unlayered Global if you value analysis that follows technology into margins, infrastructure, and economic power.
Tell us which layer will capture the value, the model, the cloud, or the application that owns the customer relationship.